Welcome to today's Friday Math Happy Hour. Today, the topics for 1324 are going to be sets and probabilities. Permutations and combinations will not be. This is not part of today's lesson. This will be for the following week. But today is going to give. It's going to be only sets and probabilities. Let me share my screen. Let me start from the beginning. Here we go. Okay. So today we are going to cover sets, subsets, proper subsets, operation on sets, intersection of two sets, union of two sets, disjointed sets, Venn diagram, introduction to probabilities, and basic concepts of probabilities. I believe this covers chapter 8, 8.1, all the way to about 8.4. Okay. So let's start with sets. Before we start, we have to go over some definitions. Okay, this section requires like many definitions, so we can know what we're talking about. So sets. A set is a well-defined collection of objects. Okay. Examples of sets. Well-defined collection of objects. For example, number one, all the students in my math class. You see, that is well-defined. Number two, letters in the alphabet. That's also well-defined. Now, let me show you an example of a statement that's not defined. For example, the collection of young adults. That's not well defined. This is not a set. Okay, now how can we make that a set? You see, we can make it a set by adding a few words to the statement. For example, the collection of young adults between the ages of 18 to 29. You see, because young adults, here at the beginning on the one that's not defined, is not defined. The collection of young adults, it's what is considered young adults. That's why on how can we make it a set? You see, now it's well defined by saying the ages of 18 to 29. Okay, now that's well defined. That's how a set has to be. It has to be well defined. Okay, now capital letters such as A, B, and C are used to name sets. Each object in a set is called a member or element of the set. Set braces are used to enclose objects in a set. Example, this means, right, capital A means set A equals the elements 3, 4, and 5, or the members 3, 4, and 5, right? Like we said here on the definition, members or elements. For example, 3, 4, 5, they're considered members. You can say members or you can say elements. Okay, this is how you read it. Set A consists of elements 3, 4, and 5. That's a correct vocabulary. The symbol here, guys, looks like an E, right? That symbol means is an element of the set. And the symbol with a slash over it, it means it's not an element of the set. Okay, now, say we have the set from the previous example. Set A with elements 3, 4, and 5, right? That's given. Now, you can say 3 is an element of set A, right? Because 3 is in set A. Or you can say 3 is an element of the set 3, 4, 5. You see, because 3 belongs in set A. So that's how we use the symbol. And here's the correct wording. 3 is an element of set A, or 3 is an element of the set containing 3, 4, and 5. Okay, this is also 2. 2 is not an element of A, right? Because 2 is not in the set A. Or 2 is not an element of the set containing the elements 3, 4, and 5. And this is how you read it. 2 is not an element of set A, or 2 is not an element of the set containing 3, 4, and 5. Empty set. An empty set. Here are the symbols for empty set. Okay, it's like a O with a slash over it, or the set braces with nothing in there. You can use either or. Okay, so these are the symbols. Equal sets. Equal sets are sets containing exactly the same elements. Example, equal sets, right? For example, the set 3, 4, 5 is equal to the set 5, 4, 3, and is equal to the set 4, 3, 5. In other words, for sets to be equal, they have to have the same elements, exactly the same elements, and the order does not matter. Okay, those are equal sets. Okay, now, sometimes we describe a set by a common property of its element rather than by a list of its elements. For example, a list of elements are these right here, right? The list is the set 3, 4, 5. That means a list. But there's another way you can describe sets. Okay, this other way is it can be expressed with set builder notations. Okay, let me show you an example. For example, it can be in this form, right, with set builder notations. Here's how you read the statement here. The set X, right? The set X of elements X such that this line like that, guys, that means such that X has a property of P. Okay. Well, this is how you read. What's in blue, right? That's how you read the set here. Now let me cut it down, symbol and letter by letter and word by word. Okay. The set, right? The set here on top. The set, right? It means this whole thing. That's my set of elements X. The X here, guys, means the element of X. The line means such that X has a property of P, right? So this is how you read it, okay? And like I said, I just broke it down and symbol by symbol, letter by letter. That way you guys can know how to say it properly. Example. Okay, now here it says to list them, right? So we have to list them. It says list the elements in the given set. The set X such that X is a natural number more than 5 and less than 8. So how do we list them, right? So it's going to be 6 and 7. Because a number, right, a natural number more than 5, right, it doesn't mean it's equal to 5, just more than 5 and less than 8. So the answer would be the set 6, 7. Let's try B. The set of such element X such that X is an integer and the integer is between -3, right, and 1, and including 1. So X is between -3 and 1, and 1's included because it has the less than and equal to, right? And the -3 is not included because it doesn't have the little like the mark on the bottom. So -3 is not included, so it's going to be -2, -1, 0, and 1. That's how you list them. Okay, like we said earlier, this set can, the wording can be expressed and here, like it says 6, 7, the set 6, 7, and also the set -2, -1, 0, 1. That's how we identify the set here for A and B. Now there's something that you guys have to know. Okay, need to know. At times they're going to be asking you something about whole numbers or counting numbers, right? If you guys don't know about these numbers, you're not going to be able to answer the question properly. So keep in mind that whole numbers, they start with 0 and they go all the way to infinity, right? They start with 0, they go all the way to infinity. Counting numbers are the same thing as natural numbers. You see, it means the same meaning. Those, they begin with 1 and they go all the way to infinity. So I repeat, whole numbers, they start with 0 to infinity, and counting numbers, they start with 1 and they go all the way to infinity. Okay, now these are actual examples from the book. Okay, I believe this is some from the homework. Here, all we have to do is state whether the statement is true or false. Okay, so for example, number 1, 3 is an element of the set of elements containing 2, 5, 7, 9, and 10. Is that true or false? This is going to be false because 3 does not belong in the set here. So it's false, and here's the reason why. 3 is not an element of the set. Look at number 2. 2 is an element of the set 2, 5, 7, 9, and 10. This is true because 2 is an element of the set. That's true. Okay. Look at number 3. 6 is not an element of the set 1, 3, 5, 7, 9, and that's true again because 6 is not there on the set. And here's a correct wording: 6 is not an element of the set. Number 4. It says 4 is an element of the set 2, 4, 6, 8. This is false. Why? Because 4 it is in the set. Look at number 5. Here are sets, right? So these are saying that they're equal sets. The set containing the elements 1, 2, 3, 4 is equal to the set containing the elements 4, 2, 3, 1. This is true because every element on the first set have the same elements on the second set, or both sets have the same elements. Look at number 6. The set containing the elements A, B, and C is equal to the set containing the elements A, B, C, and D. This is false. Why? Because the first set does not contain the element D. And here's the answer from the book. Both sets do not have the same element. The first does not contain the element D. Look at number 7. The set, all the whole numbers, right, greater than 5 and less than 9 is equal to 6, 7, and 8. Remember, right? It says all the numbers. So this is going to be, right, true, right? Because greater than 5 means not 5, but it's going to be 6, 7, 8. But it cannot be 9 because it's saying less than 9. So this is answer is 6, 7, and 8. Now, number 8. All natural numbers not greater than 4 equals the set of 0, 1, 2, and 3. Remember what I said on the previous slide. Remember I said that you need to know natural numbers do not have 0, right? They begin with 1 and to infinity. So this answer is false because 0 is not a natural number. Okay. Look at number 9. The set X such that X is an even integer between 5 and 19, right? Even integer. So let's see. So we got the 6, we got the 8, we got 10, 12, 14, 16. This is false because what's missing? The 18 is missing. Okay. Number 10. The set X such that X is a vowel is equal to the set of A, E, I, O, U. And that's true because those are all the vowels. Okay. Now let's continue. Now we come to more definitions. What are subsets and proper subsets? Okay, but before we do that, let's explain the universal set. The universal set is a set that contains all of the objects being discussed. And right now, later on, I'll show you examples of each one of these. Now comes subsets and proper subsets. Okay, now, here are the definitions for subsets and proper subsets. A set A is a subset of set B, right? So this is a notation for subset. It looks like a C, right, with a little slash on the bottom. That means subset. Written as A is a subset of B, provided that every element of A is also in B. Okay, that's something that we gotta know. Every element in A is also an element in B. Now, the set A is a proper subset of a set B, and this is a notation. A is a proper subset of B, right? So it's almost the same thing for subset and proper subset, but the proper subset doesn't have the little slash on the bottom. Okay, and this is what it means. If every element of A is an element of B, but B contains at least one element that is not a member of A. And then it says here, when A contains an element that is not in B, then A is not a subset of B. And we write it as A is not a subset of B. Okay, now I recall, guys, when I was taking this course back about 2005, something like that. To me, this was kind of confusing at first. So what I did, I recall that I put the definitions on an index card. And that's why every time that I was trying to do a problem, I would look at the index card with definitions to make sure that I understood what they were asking for. So my advice to you guys, if you want, write those on a index card and make sure that once you do one of the problems, make sure that you take it out. That way you know exactly what they want. Okay, and to me that helped me. Okay, now these are more more definitions. For any set A, right? Any set. the empty set is a proper subset of A, and also the empty set is a the empty set is a subset of A, and A is a subset of itself. A is a subset of itself. Okay, and right now I will show some examples of everything that I've discussed here for the definitions on this slide here. Examples, okay? Here are the examples. Example A, the set A has the elements A, B, and C. And the set B has the elements A, B, C, and D. And the set C has the elements C, A, B. Okay? Now, these are also examples from the book, exact from the book, right? So this is why this is how you read it, right? So set A is a subset of B, right? And here's why, right? Because this is a definition. Every element in A is also in B. That's why this is true here. Look at B. A is a proper subset of B. This is true, right? Because every element that's in A, which is A, B, and C, is also in B, A, B, and C. But B has another element that's not in A. That's a definition. Every element of A is an element of B, but B contains at least one element not in A, which is D. Look at look at C. It says a set B is not a proper subset of A. This is true, right? Because every element in in B is not in A, right? Because of this missing. And again, every element of B is not in A, which is true. Okay. Look at D. Remember the symbol? The symbol here means subset. A is a subset of C. Let's see. A has A, B, and C. And C has C, A, and B, which is the same thing, right? So it is true because every element in A is also in C. Well, let me go back. Look at E. A is not a proper subset of C. Let's see. Let's go here at A, right? This is A, it has A, B, and C. And C has the same elements, C, A, B, right? But they're in different order. But for it to be a proper subset, set C has to have another element that's not in A, right? That's why this is correct, because A is not a proper subset of C. And now for F, the empty set is a proper subset of A. It is true, right? Because remember the definitions? The empty set is a proper subset, and a subset of every set. Okay. This is just to get you going, guys, how we use these definitions here. And these are all the true statements, the reason why. Okay, now I believe this is from the homework also. I believe I got this from some of the homework problems. I think there's about 6 or 7 of them. Oh no, there's about 8 of them. Okay, now here, these, like I said, these are actual from the book. 11 all the way to 19. Okay, here, guys, they give you the set A, they give you set A, they give you set B, they give you set C, and set D, and E, and this is a universal set. The U, that means universal set, which means these are all the elements being considered. Okay, the universal set. So it says here, insert. This means proper subset, right? Proper subset, or not a subset to make the given statement true. I believe this would have been a little bit better if they had another choice. For example, maybe subset, proper subset, or not a proper subset. But this is how I got it from the book. Okay, so they're going to put the proper subset or not a subset. This means subset, like the C with the slash on the bottom, and the C by itself, like the C here, guys. That symbol means proper subset. Okay, so let's see. Let's go to A and U. A and U, right? And the universal set. So check this out, guys. So set A has -4, 0, and 4, which are also on the universal set, -4, 0, and 4. So the correct choice will be the proper subset. Okay? And there's the explanation. Every element of A is an element of U. Of U of the universal set. but U contains at least one element, not an A, right? At least one. It contains about 5 of them. Okay, now let's go to E and A, right? So E is the set containing the element -4. And A is -404. So this will be the same answer as 11, right? Because every element in E is also an element of A, but A has at least one element that's not in E. And that's the correct response. Every element of E is an element of A, but A contains at least one element not in E. Now, let's reverse it, right? So now we're going to put set A first, and then set E, right? So we look at set A. Set A contains -4, 0, and 4. And set E contains the element -4. So this will be not a subset. Why? Because every element in A is not in the in set E. And again, every element of A is not in E. Elements 0, 4 are not in E. Now look at number 14. Right, we have B. B contains the elements -3, -2, -1, 0, 1, 2, and 3. And C contains -4, -1, 0, and 4. So then, right, so then the answer is going to be this one here, right? Not a subset, because every element in B is not in C. Okay. Now look at number 15. The empty set is either a proper subset or not a subset. It will be a proper subset, right? Because remember the definitions? So every the empty set is always a subset or a proper subset of any set. So the answer will be here the first one, which is the proper set symbol. Okay. And like I said earlier, the empty set is a subset and proper subset of any set. Now look at number 16. The set containing the elements 0 and 1. Let's see what D has. D has 0. So again, the elements 0 and 1 are not in set D because only the 0 is in set D, so we're missing the 1. So this will be the second answer, which will be not a subset. And there's a reason behind it. Every element of the set 0, 1 is not in D. Element 1 is not in D. Now, let's reverse it, right? Let's reverse it. So since D is first, let's look at D. D contains the element 0. Now, is 0 in the set 0, 1? Yes, it is, right? So the answer will be a proper subset. So every element of D is an element of set 0, 1, but set 0, 1 contains at least one element not in E. That's the explanation. Let's look at number 18. We have D first, so let's look at D. D is a set containing the element 0. And B is a set containing -3, -2, -1, 0, 1, 2, and 3. And we notice the element 0 is there. So this will be a proper subset. Every element of D is an element of B, but B contains at least one element not in D. Now let's look finally at 19. We have A, which is -4, 0, 4, and we have C, which is -4, -1, 0, and 4. So the answer here will be the proper subset because every element in A, which is -4, 0, and 4, is also an element in C. There's a -4, the 0, and the 4. So the answer will be the proper subset. Okay. And this is how you read it. Every element of A is an element of C, but C contains at least one element not in A. Now, guys, so please, guys, go back to this PowerPoint after I'm done, and actually read what it says here right in red. That way you can have a better understanding. And the way I did this PowerPoint was assuming that you guys actually don't know nothing. This way, whatever you know will be a bonus because I always try to target the students that actually struggle in the class, right? So if I do that for every of my PowerPoints, then whatever stage that you are, you'll be able to follow. Okay, well, let's continue. Now comes subsets. It says here, list all the possible subsets for each of the given sets. Okay, sis, to list them, right? So we have to list them. So recall, set A is a subset of set B, right? So this is how it's written. A is a subset of B, provided that every element of A is also an element of B. So let's do A part. So, right, so we start with the empty set, right? Because the empty set is a proper subset or a subset of every set. The empty set, right, belongs to the set 4, 6. Now we're going to take them one at a time. So we're going to put the set 4, right? So the set with element 4 is also a subset of the set 4 and 6. Now we're going to take the 6 by itself. So the set with element 6 is also a subset of the set 4 and 6. Now we take them two at a time because every set is a subset of itself, right? So how many do we have? 1, 2, 3, 4. Here it says to list them, but I believe also in some of the homework it will say to how many, right? So if it says how many, you don't have to list them. All you have to do is give the amount, which will be 4. A set with 2, okay, check this out. A set with 2 elements, right? 2 elements has 4 subsets. And right now there's going to be a pattern for this, okay? But let's do let's do B, and that way we'll get the pattern. So again, right, we have 3 elements now, okay? We have 3 elements here. So we start with the empty set. The empty set is always a subset of every set. Now let's put them like we did over here on A. Let's have them individually. So set A with element A, right, is a subset of the set A, B, and C. Now let's use B. The set with element B is also a subset of the set A, B, and C. And then C, right? So this is the only way it can be, right, with only one element. Now let's put them in pairs. Now let's put 2 elements. A and B is a subset of the set A, B, and C. Now let's try A and C. The set with elements A and C is a subset of the set containing the elements A, B, and C. Now what's the other combination? Will be B and C. The set with elements B and C is a subset of the set containing the elements A, B, and C. Right, so this is the only way, right, we can get in with pairs. Now let's do it with 3s, right? Because a set is always a subset of itself. So these are the list. We have 1, 2, 3, 4, 5, 6, 7, 8. A set with 3 elements has 8 subsets. So if it's asking to list them, this is what you have to do, right? List them, like for A and for B. Now, here's the formula, guys. If they ask you how many, right? How many subsets are there? If they ask for the number, here's how you get your answer without actually listing them. A set of n distinct elements has 2 to the n subsets. Okay. For example, right? How many elements were here on A part? There were 2, right? So you're going to have 4 because 2 to the second power is 4. Look at B, right? We had 3 elements. So 2 to the third power will be 8. Okay, now this is also from the book, number 20, number 21, and 22. So how many elements are here, right? 1. So the answer will be 2 because 2 to the first power is 2. 21, we have 1, 2, 3, right? So it's going to be 2 to the third power because we have 3 elements. So 2 to the third power equals to 8. Now x is a whole number less than 5. So won't it be 4? No, it's going to be 5 because we start with 0. So it's going to be 0, 1, 2, 3, and 4. So there's 5 elements. So 2 to the 5th power will give us 32. Right? If they ask you to list them, for example, if you have 5 elements, it's going to be like many subsets, but there's going to be 32 total. Right? That's why I believe in the homework they will only ask you to list them, I believe, at the max if there's 4 elements at the max because it's going to be 16. But more than 4, they're not because there's too many for you to list. Okay. Okay, now comes operation on sets. Okay, operation on sets. It says given a set A in a universal set U, the set of elements of U that do not belong to A is called the complement. The complement of A is written as A complement. You can say A prime or not A. That's how you read the A with a little comma on top, right? You read it as A prime or not A, or the complement. For example, okay. Now we're going to be getting into actually working out some problems here. With sets. For example, this is my universal set, right? The universal set is from 1 all the way to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And set A is equal to 1, 2, 3, 4. So A complement, right? This is how you write it in a Venn diagram, right? This is going to be A. And this is going to be not A, right? Because U is this Venn diagram here, like the box here, or the rectangle, right? So all these numbers, 1 through 12, is what's being considered. So if this is set A, outside the set is not A, or the complement of A. Now this is how we list them. Okay? This is find the complement of A, or you can also say A prime or not A. I like to say not A instead, because it makes more sense. Not A. So check this out. If it says not A, it's not going to be not 1, right? Not 1, not 2, not 3, not 4. So what's left? 5, 6, 7, 8, 9, 10, 11, 12. That's your answer. Okay, now how do we represent that in a Venn diagram? That's my universal set. So set A will be 1, 2, 3, 4, right? 1, 2, 3, 4. That's set A. And not A means all the rest will be outside the circle, outside the set, but inside the rectangle, because this is the universal set. Everything's being considered is here enclosed. Again, this is A. And not A, or the complement of A, is what's outside the circle or the set. It doesn't matter where you put them, as long as they don't go inside the circle, nor they go outside the rectangle. So this is how you represent it. Okay, now, here comes intersection of two sets. That intersection has another word, right? It means and. And means intersection. Okay, now, given two sets, A and B, the set of elements belonging to both sets, A and B, is called the intersection of the two sets. And this is a notation. A, that symbol means intersection, like the upside down U means like intersection. But at times, students, they don't understand that, okay? So I always kind of have an alternative. I like to say also elements belonging to both sets, or what do they have in common? This is what I like to say when I teach this class. Why? Because at times students don't understand intersection or sets belonging to both sets, even though it's kind of straightforward. But at times I like to use what do they have in common, right? Both sets, and I believe this wording, what do they have in common, at times it makes more sense to the students. Okay. Now let's do examples here. This is a universal set, which is the same set as before, 1 through 12. We have set A is the same thing as before, 1, 2, 3, 4, but set B is the set of elements containing the element 2, 4, 6, 8. Okay, now how do we represent it in a Venn diagram, right? So first, this is what it means, right? A intersects B, or A and B, which means what does set A and B and set B have in common? They have in common a 2. They have in common a 4. So that's your answer, 2, 4. Okay. Now, how do we represent it in a Venn diagram? You see, that's my universal set. Okay, first, when you're going to do this set here, guys, this is set A and this is set B. You always first start with it where they intersect, or what do they have in common, right? So the 2 and the 4 are going to go here. You see, here's where they intersect, or what they have in common, right? Now, let's do it. Let's plug in all the numbers in the correct set. So, right, so A intersects, you always start with A intersects B, which will be 2 and 4. Now let's go to set A. Set A contains 1, 2, 3, 4, right? right? So I already have the 2 and the 4, right? And set A. What's missing? The 1's missing and the 3 is missing. You cannot put them in here inside what they have in common, what set A and set B have in common. Why? Because 1 does not belong to both sets, so it has to be in set A, but not inside this little union here. What they have in common and what they share. Now comes set B, right? So set B, we have 2, 4, right? 2, 4 already here in set B. So then we need to put the 6, we need to put the 8. Now we have to go right to the universal set. We have to list all the numbers or the elements that are not in A and B, right? So for example, we got 1, 2, 3, 4. What's missing? The 5 is missing, so we have to put the 5 on the outside. We got the 6. What's missing? The 7 is missing. We got 8. Now we're going to put 9, the 10, 11, and 12. That's how you represent the Venn diagram. Okay, now comes disjointed sets. It says for any set A and C, if A and C are disjointed, then A does not intersect C. It will be the empty set. In other words, A, when they say disjointed, it means that they don't have nothing in common. Okay, now for example, we added set C from the previous example. Right, set C is 5, 7, 9, 11, and the universal set. And set A and set B are the same as before, but we added a set C. This will explain disjointed sets. Okay. So what do the sets A and C have in common, right? What do they have in common, A and C? Nothing, because A has 1, 2, 3, 4, the elements, and C has 5, 7, 9, 11. They don't have nothing in common, so the answer will be empty set. It'll be that notation, right? Or you can put the braces with nothing inside. Now here's how you represent it. Universal set, we got set A, we have set C, right? They don't have nothing in common. That's how you write it. Now let's actually list them in the universal set. We have set A, right? So A is 1, 2, 3, 4. And C is 5, 7, 9, 11. Right, but we're not done yet, right? Because now we have to put the elements, right? Because this is my universal set. So the elements that are not in A and C have to go outside the sets, but within the rectangle, right? Because that's a union. So we got 1, 2, 3, 4, 5. What's missing? The 6 missing, so we need to put the 6. There's my 7, we need to put the 8. There's my 9, we need to put the 10. There's my 11, the 12 is missing. So that's how you represent it. Now comes or the union. Okay, it says here, given two sets A and B, the set of elements belonging to set A or B is called the union of the two sets. And this is how you write it, A union B, or you can say A or B. It says here, list all the elements of both sets, but do not repeat. This is how I like to explain it to my students. Okay, you list all the elements of both sets, but you do not repeat. Example, right? We're going to have the same sets as before. The universal set, same as before. Set A and set B, same as before. So find A union B. I always tell my students, so they won't make a mistake, to always put everything in A first, right? Because it says first, everything in A. There it is, 1, 2, 3, 4, that's A. Now you're going to go to set B. If the element in set B is already listed, you don't write it again. For example, is a 2 in set B already in the set? Yes, it is, right? So we don't write it again. How about the 4? The 4 is already there, so we don't write it again. Or we don't repeat it. Is the 6 there? No, so we're going to put the 6. Is the 8 there? No, it's not, so we're going to put the 8. So that's my answer, guys. That's how you represent A union B. Okay, now here's how you do it in the Venn diagram, right? That's U. This is A. That's B. And together, this is A union B. All this together here. That's A union B. Okay, now, I think this will make more sense once we do it by listing the elements. I mean, inside the set and also in the universal set. So, set A. We have, if we want, we can start even what they have in common, right? We have 1. Remember the 2 and the 4 they have in common, right? So they go there. Then we have the 6 and the 8. That's going to represent A union B. Now, we have to take into consideration, right, again, universal set. So whatever's not here inside the both sets, they have to be outside the sets, but within the rectangle, which represents a universal set. So we got 1, 2, 3, 4, the 5's missing. We got the 6, so the 7's missing. We got the 8, now we put the 9, the 10, 11, and 12. That's how you represent it. Operation on sets. It says here, let A and B be any set with the universal set signifying with U signifying the universal set. Then the complement of A is written as right as before, A prime or a complement or like I said, not A. Okay, this is how you write it. The complement of A is equal to the set with elements X such that X is not in A and X is an element of U, which is a universal set. Okay, my notation. This is like a sum up of what we just went over. The intersection of A and B, right? Here's how you write it. A intersects B is equal to the set with X elements such that X is an element of A and X is an element of B. See the intersection. Now comes the union of A and B. You write it A union B is equal to the set of X elements such that X is an element of B, or X is an element of A, or X is an element of B, or both. And that's how you describe it in a Venn diagram. Okay. Now this is also from the book exercises. Okay. Now they want you they give you this is my universal set. It has A, B, C, D, E, 1, 2, 3, 4, 5. Set X has A, B, 1, 2, 3. Set Y has B, D, 1, 3, 5. And set Z has the elements B, 2, 3. Now here says list the members of each of the given sets using set braces. Okay, now since we have the complement of X and the complement of Y, let's list everything here. That way we already have it. We already have the complements. So for example, if that's set X, we had it from here. A, B, 1, 2, 3. So not X or complement of X will be, we're going to go to the universal set. So it'll be not A, not B, not 1, 2, 3. So what's left will be C, D, E, 4, 5. This is a complement of X. We got the set Y. And same thing, this is a list of complement of Y or not Y, right? So we go back to the universal set. So we have B, so it's going to be not B, D, not D, not 1, not 3, not 5. So this is what's left from the universal set. Now that's my Z, right? Says here we don't need to use the complement of Z. Okay, here's where we stay then. Okay, so here we go. Everything is here on the right. Okay, for us. It says what does X intersects Y. So what's my saying? What does X and Y have in common? They have in common a B, right? 1 and a 3. That's my result. Okay. 24, X union Y. Okay, again, remember what I said, that we're going to put the first set, the set X, we put them all down, which is A, B, 1, 2, 3. Now we're going to go to Y. Okay, here's Y here. B, is a B already there? Yes, it is. So we don't put it again. We have the D. Is D already there? No, so we're going to put D. Is the 1 already there? Yes. Is the 3 already there? Yes. Is the 5 there? No, so we're going to put the 5. That's my result. Okay. Now, 25, the complement of X, right? We already got the answer here on the right. So that's my answer, right? On the right. C, D, E, 4, 5. Now, 26, the complement of X intersecting and the complement of Y, right? So we already have him here on the right in red. So what does X and Y have in common? Not X and not Y have in common. They have in common a C. Let's see, an E, and a 4. That's my result. Okay. 27. The complement of X intersection Z. Here we go. So they're here on the right complement of X and Z. What do they have in common? Let's see, a C, no, a D, no, E, 4, 5. So it's going to be the empty set, right? They don't have nothing in common. Right? Remember I said these two symbols are for the empty set, so you write either one or the other. Okay, now let's go to 28, which is the last one here. 28, right? First we have to follow the order of operations, which is PEMDAS. So first we're going to do what does Y and Z have in common, right? Or Y intersects Z. So let's go up here on the right. There's my Y, there's my Z. So they have in common B, right? They're both in both sets. And a 3. And that's it, right? So now let's put Y intersects Z here on the left. Now, right now we're going to do union, right? X union B3. So X union, X union, the set containing the elements B and 3. Now, remember when we said when it's union, first you start with everything that's in the first set, which is A, B, 1, 2, 3, right? That's what set X is, A, B, 1, 2, 3. Then you go to the other set. If it's already there, you don't write it again. Okay, here we go. Is a B already there? Yes, it is. Is a 3 there already? Yes, it is. So this is my answer. Just be whatever is in set X. That's how we do these type of problems here. Okay, now, this is number 29 also from that section. Okay, they give you from the Venn diagram, it says list the universal set A, the universal set A, set B, set C, and the intersection of set A and B, the intersection of set A and C, the intersection of B and C, and the intersection of all three, A, B, and C. Okay? So this is my universal set, which is going to be A, right? So it's going to be A, B, C, D, E, F, G. So set A is going to be A, D, E, G. Set B is going to be B, right? B, D, F, G. Now set C is going to be C, E, F, G. Now comes the intersection between A and B. Okay, what does A and B, where do they intersect? This is A, and this is B. Won't the answer be DG, right? Just these two. Now let's do the intersection of A and C, right? We have A and C. So this is my answer, right, for the intersect. So the answer will be EG. Now let's do the set B intersect C, right? This is B, and this is C, right? So this area is where they intersect, which will be FG. Now let's do the last one, right? What do they all have in common? What do they all intersect? Will be this little area here, which will be G. That's how you extract that info from the Venn diagram. Okay. Now this is the hardest it gets, guys. This is it right here. Everything that we've done, here's where you apply it in a problem like this one. Okay. It says, this is number 30. 60 people were contracted and responded to a movie survey. The following information was obtained. Okay. It says 6 people like comedies, dramas, and science fiction. Why do I put it in red, guys? Because that's where you start. You see, this is what all three sets of movie response have in common. The comedies, dramas, and science fiction. Then it says 13 people like comedies and dramas, 10 people like comedies and science fiction, 11 people like dramas and science fiction, right? 12 people like comedies, 21 people like dramas, 25 people like science fiction. So first, they want us to draw a Venn diagram that represents the situation here. So let's start. How many people are there? 60, right? So then we're going to start here, guys, right? So here's how we do it. So 6 people like comedies, dramas, and science. So this is where we start, right? Where they all intersect, which is in red. which would be this area here. Here is where they all intersect. Okay, so let's do this first. Let's see, this will be comedies, this will be dramas, and this will be the science fiction. Okay, now here's where we start, right? Start intersection of all three, which will be this area here. That's 6. Now we just go in order. Let's get the next one, right? 13 people like comedies and dramas, right? That's why we have C and D. This is comedies and dramas. So this area here, right, is where C intersects D. So it has to be 13. But since there's already 6 there, this has to be 7. Okay. Now let's do 10 people like comedies and science fiction, right? So comedies and science fiction will be, this is comedies, this is science fiction. So it's going to be, this area represents the C intersects S. So we have 6, we need 4 more. Okay. Yes. Does somebody have a question? Okay, let me continue then. Now, D intersects S is equal to 11, right? So D means dramas and science fiction. So dramas and science fiction will be this area here. So we got 6, so this will be 5. That's a missing part there, 5. Now, we go to set C, right? Set C is 26. Already got 4, already got 6, so that's 10. And 7 is 17, so what's missing? 17 minus 26, the answer will be 9. So 9 goes there. Now let's do dramas. D equals 21, right? So dramas, 21. All this represents the dramas. We got 11, right? 6 and 5 is 11. 7 is 18. So what goes here is going to be 3. Then let's do the science fiction, which is 25, right? Which means this whole area represents science fiction movies. We got 4 and 6 and 5, that's 15. 15 minus 25 is equal to 10. Okay, now we need one more thing, right? How many are in the outside? How do we get that? Okay, there's a total of 60, right? So we're going to add all these right here, all that are in this, and we're going to add the 9, the 7, the 6, and the 4, the 3, 5, and 10, right? Is equal to 44. Since there's 60, it's going to be 60 minus 44 will give us 16. So X is equal to 16, which means there's 16 that don't like none of the movies. Now let's answer the A, B, and C, and D. This is already A, right? A is the first part, which is a Venn diagram, right? It's completed. Now from the Venn diagram, we're going to be able to answer B, C, and D. It says, how many people surveyed like comedies? Okay, let's go to comment. They like comedies, but neither drama nor science fiction, right? So they like comedies, so we like comedies, but they don't like dramas nor science fiction, so it's only going to be 9. There's your answer, is 9. Okay, now look at C. How many people surveyed like dramas and science fiction, but not comedies, right? So let's go to, they like dramas and science fiction. So they like dramas and science fiction, they like dramas, right, and science fiction. So it's going to be, right, so it's going to be 3 plus 5 plus 10, which will be 18, right, because this is dramas and science fiction, but not comedy, so not these right here. So only these right here on the bottom. That's why it's 10 plus 5 plus 3, which is 18. Now for part D, how many people like none of the movie styles? So the answer will be what's not on any of the sets, but it's inside the universal set. The answer will be 16, which will be the value for X. Okay, guys, that's how you answer these type of problems. And I believe almost every instructor gives one of these on the exams, because I do. Okay, so make sure that you can come back to this PowerPoint or to this presentation, and that way you have a better understanding. Okay, now I think we need like four more slides here. This is introduction to probabilities. Okay, it says a process by which we observe something uncertain. After the experiment, the results of the random experiment is known, which is a random experiment. The sample space is a set of all possible outcomes of a random experiment. For example, for a coin flipping, right, the sample space will be just heads or tails, because if we flip a coin once, it'll just be heads or tails. That's my sample space. Rolling a fair die, sample space. Well, a fair die means that that the die is not loaded, right? Every every side has a equal opportunity to be rolled. So it can be a 1, a 2, a 3, or 4, or 5, or a 6. So this is my answer. Okay, now to find the sample space of an experiment, at times it's easier to draw a tree diagram. This is what I mean. Find the sample space of flipping a coin twice. Okay, so here we go. Flipping a coin twice. There's my first flip. It can be a heads or it can be a tails. This is my first flip. Now second flip, it can be heads, and then again it can be heads or it can be tails. If it was tails first, right, then it can be heads again or tails. That's where we draw a tree. So what's my sample space? It's going to be, right, it's going to be S, it's going to be HH, heads, heads, it's going to be heads, tails, tails, heads, and tails, tails. So that's my sample space. There it is. So it's going to be heads, 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 tails, tails, heads, and tails, tails. Okay, now, event is an outcome of a set of outcomes of a random experiment. Here's what I mean. An event is a subset of a sample space. For example, if the sample space of flipping a coin is heads or tails, right? Then one event is the event that heads shows up. Okay, now checkpoint. Suppose the die is tossed. Write the given events in set notation. Right here, they want you to write the set notation, right? So the number showing is less than 3, right? This is my sample space, right? So it's going to be less than 3 will be 1 or 2. That's my answer. For B, the number showing is 5, right? So it's going to be a 5. That's it. For C, the number showing an 8 is going to be the empty set because there's no 8 there. It's only 1 through 6. The die showing is an even number. Well, it's going to be 2, 4, 6. Right? Those are my even numbers. That's how you represent the situation here or what they're asking for. Okay, now comes basic probability. By this definition, the probability of an event is a number that indicates the relative likelihood of the event to take place. The N of E means the number of elements in the event. The N of S means the sample space, the number of elements in the sample space. Okay, checkpoint. Suppose a third die is rolled with a sample space S equals to 1, 2, 3, 4, 5, 6. Give the probability of each of the following events. The die shows an even number, right? So it's going to be 3. So it's going to be 3 out of 6. Right? This is my definition. The probability of an even number, there's going to be 3 even numbers, and the sample space is 6, so the answer is 1/2. The die shows a number less than 10, so it's going to be 6 over 6, right? Because all these in the sample space are less than 10, so the answer will be 1. 6 over 6. The die shows an 8. That's going to be 0, right? Because there's no elements that are 0, so the answer will be 0 over 6. The answer will be 0. Okay, and this again, this is a definition, which is the probability of the event is equal to the number of the event over the number of the sample space. We have like about three more slides. Let's see if I can get them. Well, it's already time, but it'll take me about 2 or 3 minutes. Okay. It says here, a single playing card is drawn at random from an ordinary 52-yard card deck. Find the probability of the drawing. So first, here is actually like a picture of playing cards, right? These are called suits. The spades, the hearts, and the diamonds. There's 13 of each suit. Okay. Also, playing cards have 2 jokers, but those are not included here. Okay, now there's 52 total. So that's my sample space, right? 52. Now there's going to be 26 black and 26 red. Now face cards. What are face cards? Face cards are cards that have a face, right? These are the face cards. That's called the jack, the queen, and the king. So each suit has 3 face cards. Okay, now let's start doing this checkpoint. A queen is drawn, right, by random. So the sample space is 52, like I mentioned earlier. So how many queens are there? There's 4, right? Because there's 4 suits. There's 1 in each suit, so it's going to be 4. So 4 over 52, the answer will be 1 over 13, right? You simplify. A diamond. How many diamonds are there? There's 13 diamonds because there's 13 cards of each suit, so there's 13 diamonds. 13 over 52 red, that's my sample space, will give us 1/4. A red card, right? There's 26 black cards and 26 red cards, so there's 26. 26 over 52 will give us 1/2. A face card or an ace. Right, how many face cards are there? There's 3 in each suit, so 3 times 4 is 12. How many aces are there? Aces? There's 4 aces, so 12 plus 4 divided by 52. It'll give us 16 over 52. If we reduce it, it's going to give us 4 over 13. So this is how you use probabilities. Okay, I believe this will be the last one. Okay, or second to the last one. It says here the basic concept of probabilities. It says for any event E and F from a sample space, the probability of E union F is equal to the probability of E plus the probability of F minus the probability of E intersects F. Okay, it says here, example number 1. When playing American roulette, the croupier spins a marble that lands in one of 38 slots in a revolving turntable. The slots are numbered 1 through 36, right? There's 1 through 36 here on the roulette table, with 2 additional slots labeled 0 and 00 that are painted green, right? Here they are, the green ones. Half or the remaining slots are colored red and half are black. In roulette, the slot labeled 00 are not considered as even or odd. Now here we go. Find the probability that the marble will land on a red or an even. Okay, solution. Let the set of red be R. So I went around, guys, and I got all the R's, right? The red ones. 1, 3, 5, 7, 9, right, all the way to 36. So I did all the work for you guys, right? So I went around and I put all the red numbers there. Now let the set of even be E. So these are the ones that are even. Okay. So let's use the formula. So how many are red, right? There's going to be one. I just have, I believe it's 18. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's 18. What's right here? There's 38 total, 18 red, 18 black, 18 even, and 18 odd. Red and even, right? So we're looking for red and even. Red and even is going to be 8. Why is that? Because there's 8 that are red and even, right? There's 1, 2, 3, 4, 5, 6, 7, 8. So let's use the formula. Okay. So red union E. Right? So there's 18 over 38 plus 18 over 38 minus, there's going to be 8, right? This means intersection. That means that the ones that were red and even minus 8 over 38. So the answer will give us 28 over 38 is my correct answer. And all we do is simplify. So this is how you answer some of these type of problems. So it's always wise to list all the info and then see what they're asking for. Okay. Now let's do one more and then we'll be done. Example 2. Suppose 2 fair dice are rolled. Find each of the given probabilities. The first die shows a 2, or the sum of the result is 6 or 7. Okay, so let's use the same formula. Let A represent the event, the first die shows a 2. And let B represent the event, the sum is 6 or 7. Okay, there's all the combinations. So this is event A, right? Event A says the first die shows a 2, right? So you see the first die is a 2. You see there's 1, 2, 3, 4, 5, 6. So it's going to be 6. I mean, it's going to be 36 total, right? That's my sample space. Will be 36 total because we got 6 across and 6 down. So 6 times 6 is 36. Now for the event A, it's going to be 6. Now let's do the event B, right? Event B means that there are 6 or 7. So everything in blue adds up to 6 or 7. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's going to be 11. Now, where do the both sets intersect, right? So they intersect here on those two rare. So the probability of A intersects B, right? We got 6 over 36 plus 11 over 36. Now comes minus, right? The intersection, which means it's going to be that one, the 2, 4, and the 2, 5. How many are there? There's 2. So minus 2 over 36. Right, so my answer will be 15 over 36. And I believe this can be reduced to 5 over 12. That's my answer. Okay, now let's do B. Again, right? So the sum is 11, or the second dash was a 5. So again, this is my sample space. So the sum is 11. So it's going to be these right here. Right? These right here, the sum is 11. So it's only going to be 2. Now for the second part, the dash was a 5, right? The second dash is a 5. The second one's a 5, so it's going to be all these right here. Right? Because all the second dash is always a 5 all on the way across. So it's 1, 2, 3, 4, 5, 6. Now let's put right the intersection. Where do they intersect? Right about there. So it's going to be 1. So let's put the formula down. So it's going to be 2 over 36 plus 6 over 36 minus 1 over 36. So there's my result, 7 over 36. Okay, let me go back real quick. Hey guys, that's how we work these type of problems, guys. So I believe this is the end of my PowerPoint. I hope you can use it for to prepare for this week. And I want to thank you for let me see here. Thank you for staying like a little bit extra. Thank you.
Thank you, Mr. Isasi, for your wonderful presentation. If you'd like to download a copy of the presentation, you can go up to the top right corner and click on the box with the arrow going down while the presentation is on the screen. We do want to remind you all about our previously recorded sessions, which are available on a YouTube playlist. This session will also be available on that playlist later today. And also, link is a short survey to help us improve our TV sessions. Please take a few minutes to fill out the survey. Before you all leave, I want to share the TV sessions that we'll have next. At 1 p.m. today, we will have Dealing with Depression. And we will be back with Happy Math Hour next week, in 2 weeks, on December 1st at 11 a.m., where Math 1314 will cover basic matrix operations and inverses, and Math 1324 will cover basic concepts of probability, permutations, and combinations. Our 1 p.m. session on December 1st will be Learning Express. Thank you all for coming today. We hope you'll have a lovely weekend. If you have any questions, feel free to use the chat box of your mic, and we hope to see you again for the next Happy Math Hour. Thank you.